Alright, so let's get started. Okay, so I've made some changes in the, let's say, in the sorting. Okay, in this function. Okay, so I was not subtracting this index. Okay, so I'll remove it here, and then we will try and run this. Right. Okay. So I'll make. So you saw the values have failed. Right. Okay. And key is this. Fail I equals 1 is value max. Okay. So let me. This is redx.map.c 206. Okay. 206 right here. Okay, I can get rid of this. Okay. So basically, what I was doing is like say I have so I have this map, right? Let's take an example. Okay, what is this? 1 2 3 4 5 6 7. Okay, so 0 1 2 3 4 5 6. Okay, so I have some values, say 1 2 3. Let's put 4 a.m. All right, so the same let's say I want to insert say a key. These are keys, right? So I want to key insert and these are all zeros and the end is here. The key I want to add key 3. Okay, so we find the minimum position. The minimum position is this, right? This is the index min. Right. So in the radix sort method, what it actually does is it takes the source pointer at the address of say keys of index say I m, and then it defines a AND, which is this source plus the current value of AND, which is 0 1 2. So 2. So now our sorting. So now sorting. Let's say what is area is source. The index is 1. Let's say this position plus 2, which is 3. Okay. So now we will be sorting from here up till here, which is wrong, right? Since I just want to sort from here to only these two values need to be sorted as the value will be inserted here. So when we are turning this 0 will come in the front, and I think I can demonstrate it. We could let's okay let me comment this out, and then okay, so let me go 1 2 and then 3. Alright, so we will leave removing and all for later. Okay, great. So let me go make clean right. Isn't it clean W? Okay, right. So we go make. Right, so you actually see that the output is 1023 because it included up to this 0. which was wrong. So in order to fix this, what we will do is we want to update the something wrong with this part, which is end, right? So this defines the upper bound of the sorting, let's say, area, right? So what I want is from here from here up till here. So I can easily get this area by subtracting this and, right? We increment, we have added the and, so we go, which is, now see, when we add, the and will be incremented, so and will be up here, updated and will be here after 3 is inserted here. Then we will go, now we want this, right? So this can be this is 2 blocks, right? The area is 2 blocks, so we can apply easily compute this value by and minus im. So and is 3 here and im is 1, so there's 2. So this will not overshoot it, and when I make these changes, okay, and then we rerun the tests, then it is right. Okay, so that's it. I can get rid of this, and let's comment this out, and we will comment a lot more things than these. Let's say here, up till here. Let's comment so all tests up till here. So we have, now I'll uncomment this part. Okay, so now I can rerun the tests. And it runs fine. Okay, so we are done with this. Alright, so there you have it. All tests are passed. You can just clear these. Okay, now we move on to second. Okay, so I have implemented this. Right. Then we move on to these. Implement quick sort, heap sort, merge sort. Yep, that's done. Then compare the performance of your optimizations to the original implementations, maybe, and then use these sorting functions to create a d-array sort add. Okay, so using these sorting use this to that adds element to the d-array but sorts the array afterwards. Okay, we can do that. Radix map, so I want to, okay, what am I doing? Okay, so I want to open the d-array files, right? Do I have d-array files? Okay, source, nope. Okay, so maybe we'll go back to let me say dynamic arrays, right? Sorting and searching. Okay, so I'll go to exercise 35, sorting and searching, and then okay, didn't have a, so let me close everything here. Then okay, source, hardware, everything. Okay, So I won't be needing debug nor list, not priority queues, and not the array. Okay, so I can define certain, maybe, okay, I'll define the array, let's say quicksort, right, let's say 1. Then 2 and 3, I have heap sort, then I have merge sort. Okay, so we will use these macros as an option for sorting the array, right? Okay, so then I'm going to define another method, the array algos. Yeah, the array algos, of course. Okay, so I'm going to add a function, use these sorting functions to create a the array sort add. Okay, so we go int the array sort and add, then we'll go, we need the d array, of course, the array, then we need the compare function, and then we want the, I think, okay, what is int, should I put int the array sort technique, the array sort algo, the array sort algorithm. Okay, so the array sort add, okay, so I would also need let's say the array, so I have dot h, and I have this function over here, it should be add, where is add, push. Okay, the array push, so we push at the end of the, okay, so I want to do most of the same functionality. Let me see. Okay, then I have function to add and sort the data. Okay, so we'll have and the array sort add, we add, okay, we add at the bottom and then we simply call sort, right? Okay, so I'll go with this, right? We can perform the various checks. Let me define an error label, return -1, right? Yep. Okay, so we have check, we check the array should not be null. Okay, so array, then we'll say, what will say, can't sort a null pointed array. I'll say error invalid d array. Okay, and then we'll put a switch, Okay, first I want to add the element. Right. Okay, so I want void push int. Okay, int push. And what does it resize? Where is push, destroy, clear, push? Okay, int. So it returns a 0. The array end is greater than the array max. Return expand array. Else return a 0. And expand array underscore expand is array expand return 0. Okay, so we just, it has a defined rate of 300, right? Expand rate of 300. Okay, so then I'll go on here and first, okay, yeah, have to take the element the array get, the array remove, the array set, get static inline, and then we have free. Okay, static inline. Okay, you can declare static with inline, right? Okay. Directly destroy. Direct create. Okay, what was I looking for? Right. How do we add? Right. Right. Push with a void el for element. So I'll go void el for element. Apply void element. So first add the element in the first add the element, so we go the array push. I want to check it, check the array push array, and element should not, okay, equals 0, error, fail to add the element. Okay. Now, depending on the okay. Now, depending what? Now, depending on the, okay, so now depending on the type of, okay, I think I should check this first, right? Oh yeah, I can default to a method, right? Yeah, okay, now depending on the type of sorting algo provided, sort the array. Okay. So here the array sort algo, I can go case thus quick sort, right, case quick sort, and we break Then we have heap sort and merge sort. Okay. Okay, and I'll have a default case where um, wrong input, wrong type is provided default to quicksort, right? Okay. So now I can call these algorithms. We have this DRA quicksort, go check array and compare. Shit. What does it return? Heap sort, partition, we have static void quicksort, merge, divide, there we go. Okay, return 0. Okay, I just quicksort. Right, there we go. And merge sort returns 0. Okay, so it all should be 0, equals to 0. And we go error, fail to sort the DRA. Okay, let's just copy this. I have quick sort, heap sort, and then merge sort. I hope that's it. Merge sort, heap sort, and right, and DRA heap sort returns a 0, and this is static void quicksort, main quicksort function. Okay, partition, quicksort utility, void merge, divide, merge sort. I think I should keep it next here. Okay, so quick sort, and then we will default to this. Alright, and that's it, right? It sorts the algorithm. It sorts the array. Then what else can I do? DRA sort, that adds the element to the DRA but sorts the array afterwards. Okay, write a DRA find that uses the binary search algorithm from radix map find and the DRA compare to find elements in a sorted DRA. Okay, so do I need to check if it's sorted? Can I add a new flag? Just have a flag, right? Okay, but let's not go there. Then I want void, right, DRA find that uses binary search algorithm to, okay, we have the array. Okay, does radix map did it used to take, do I need to provide an index, or do I need to provide, what do I need to provide here? I need to provide the element itself, right? If this, okay, we check if this element is present, because in the case of um, I wanna go p dash open. Okay, maybe I'll just go to np source see the hardware and then redxmap.h redx my okay, yeah, so it takes the key but I don't have a key, so rather find that uses binary search algorithm to find elements in a sorted, right? So you would have to provide the element. Yeah, okay, so I will, there must be tests ex35 sorting and searching. Okay. Right, so I want to no, sorry, in the test, right? Test.c, yes. Okay, so it's sorted. Run test and this. Okay, now along with this I want to unsort test char star test sort add, and we return null for now, and also I want a test for, let's say, test find DRA find. Right, so then create words. Pointer to a pointer, then we are providing the values of these pointers. Okay. Okay, so we got here a get sorted strcmp, compare strcmp, test compare. Okay, I never create words is sorted, so it's sorted name. Okay, DRA is sorted words. DRA compare, and we provide this string compare. Okay, so let me focus on this one. Okay, I can add, I can try this, right? So let's sort add. I can create this. No, I don't want to create it, right? Okay. Check order again and again, right? And check order returns something. It's sorted. It returns 1, and it returns 0 if it is not sorted. Okay, so okay, it returns a 0 if it is sorted, and returns a 1 if it is not sorted. Okay, let's say let's sort. Okay, not sorted words. Okay, so it says that it should not, so it returns a 1 is 0, words should not start, words should start not sorted. Okay, so we said that it should not be sorted, then we say if it is sorted, yeah, this should be 1. Okay, so it returns a 1. Alright, So let me create say words. Okay, maybe I'll create a D array of D array create. How do exactly do that? uh, Size of element and initial size. Okay, so size of element is 0 and initial size I'll say 5. Okay, that's good. Oh, exactly, since we are storing pointers, right? So 0 5. um and then what else can I do? Then I have to add conti continuously add strings. Right, okay, so I'll go D array sort add or add sort. This will throw an error. Sort underscore add. Sort underscore add. We need the array itself. Then the element, which will be a string literal. Will it be able to do that? Because I had string literals. Yeah, I think it should be able to do that, right? So say okay, I'll go with chain. Then I need a compare function. I'll go D array compare. I cast it as a D array compare, and then str compare, and finally I provide the sorting technique. So I'll provide we have D array quick sort. Okay, so D array quick sort. Okay, so let's check. Int r equals this, and we go check r equals 0, else we go not check. I'll use mu assert equals 0. We go error, fail to add. Okay, say sort add function failed. Okay, right. Then okay, then again let me just comment these out for a while. Then I'll call this function test underscore sort. Test sort underscore add mu run test this. Okay, maybe I make this and test run. Right, says sort add function failed. Okay, sort add function failed. Oh, of course, and return 0. That's why. So we go clear make right all the array algo test sort add. Okay, so now I am going to This is fine. Let's not worry about this for now. And let's say I go Shane and then I go E. Okay, I know Shine. Right. So I would check order. How is that checking order? Is sorted. Okay. So I'll go mu assert is sorted. We have array. Okay. Sorted function field. Okay, so we go clean and we make it again and we go. That's right. So I can even take a look at it. I know if okay, let me just printf s and s. Right. Okay, maybe I can log info s and then I have d array get array and index, right? That's how it works. D array get, D array set, D array get and index, right? D array get 0 and then I have D array get of 1. Okay. So I should see that there is Shane and then Shine. Okay, Shine is obviously greater, so it is to the right. Okay. Fine. Okay. So this works. I can try. So it is sorted, so I know, but it is okay. So I'll have Shine first, then I'll have Shane. Okay, so I'll have Shine first, then Shane later, and I should have the same result. Okay, Shane and Shine. I added Shine first, then Shane comes first. Okay, right, perfect. Okay. So what I can do is I can have a let's say names, right? I feel like it should be a array of pointers, right? Was words are array? Yeah, an array of char pointers, and they should be, let's say I'll start with Shine, then I'll have Ash, and I'll have Shane, and I'll have, let's say, Z. Okay, then what I will do is I'll start a for loop for int I equals 0, I less than size of names and I plus plus, and we will perform these two things, and if at any point it fails, then we'll know that we're wrong. Let's try merge sort. Okay, right. Okay, oh, function failed. Seriously, add function failed. 72 a sorted array, so array was not sorted. I less than size of names, right, is sorted. So I'm providing, right, need to create it. Oh yeah, add result and words of I, right. A sorted array sort function failed. Lost. Okay, I wonder what is this about. Add continuously add strings. Continuously add strings. An array of pointers, right? So we add this. Okay, I also forgot to check. Let's say int r equals 0, and I go r and mu assert r equals 0, error sort add function failed. But I'll know when it fails. So let's see if it is 74. Okay, so a sorted array, it is giving quite a problem. So let me int I equals 0, I less than what is the size, dir underscore count, right, that's the size. I hope dir count, right, dir underscore count array and I plus plus, and I want to log info let's name it J and J. Okay, so I'll go pass 1. Alright, so I think and I'll have let me assert, let's see, log info pass number, and I can no, this is just some debugging. Okay, s the array get array of j, and let's run this function. Okay, so we have pass, we add shine, right. Shane shine Z. Then on the pass 4, okay, 0 1 2 3. How come it is 4 size of names? What is the size 4? So yeah, shouldn't it just yeah, that is a little concerning because, but still, okay. So I feel like we are going out of bounds here because if I is 4, clearly there is nothing right here. Okay, size of names. Maybe I should keep it 4. Is it okay now? Yeah. Okay. So cannot trust size off with this. Okay. Then we have. Okay, so I will test again with heap sort. Heap sort, and everything's great. Okay. Right, so I'm done with this. Right, so I have used sort a write a function to find. Okay, now I have to use a binary sort. Right, you would have to provide the element itself. Void element and a d array compare function. Right, the array compare function. Doesn't it have a compare? Yeah, I wish I could store, but we can store a function. If we can store a function pointer, that means we can store a function pointer, not anything else. Okay, so we have this void element here and a compare. Right, so let me implement this void start d array find. Then I have array element and a compare function. Okay, array element and a compare function. Okay, so okay, what if it is greater than 0, then I think okay, so I will declare, let's say first of all we check array should not be null, right? Error invalid d array, and check element should not be null, error. What if, well, yeah, I cannot do that. What if that element is 0 for integers and all, right? So I'll just can't check if element is null as it may be 0 in case of integers, and it will throw an error regards. Throw an error. Okay, so I feel like I should put it like this. Then what we will do is declare a low equals 0 and high equals d array count, which is say array -1, right? Then then we start while low is less than or equal to high, right? And in here we will declare a middle element is equals to low plus high minus low divided by 2. This will all be a integer, because integer and integer operations on integer and integer will always result in an integer. Then I want to get void temporary element is equals to d array get array and middle. Right, now we must check, but it wouldn't, yeah, it will never be null, because we are within the bound, so there is bound to be data within it, so we don't need to check if temp is null. Okay, then we go if the array okay, cmp. Alright, so just almost there. Alright, so this function the array compare, I forgot how it used to work. The array compare, the array compare function. Okay, string. Maybe I'll just quickly look in here. Say strcmp. Hey, yeah, show me more. What is okay, no, okay, so void array void element compare. I feel like I have compare strcmp. Okay, strcmp. Right, if this element is greater than the next element, first is greater than less, then it is okay. So we'll check if our current element, which is temp, and this element, if it is greater than 0, this means temp is greater than, so it is to the right, so we need to decrease high. We say high equals middle minus 1, and we go else if compare temp and el is less than 0. Right, so we go this case is equals to middle plus 1, and finally we have found the element and we return it. The array get array count. Okay, we simply return temp, and if no element is found, we return null. Okay, so there you have it. Alright, then I feel like I should destroy this array, right? There is a function to destroy. Yes, but because I have not allocated any space, I don't feel like I need to destroy it. We have the array array equals create. I think there was a create underscore words array should not be equal to null. So error, fail to create the array. Alright, then I want to sort. Yeah, I'll just call a sorting function, doesn't really matter. Int r equals the array, and we have underscore quick sort array. I need the array and the compare function, right? So the array compare str compare. Okay. Then insert r should be equal to 0. Error, fail to sort the array. Right. Maybe I should let them run, but I'm only focused on this, right? Okay, so it is sorted. Now let's say I want to find 13234. Okay, so I will go char star s equals, will I get a reference? Yes, I will definitely get a reference. Let's say the array find array. Okay, first of all, let me check okay, so let's find a word which is not in the array. So I'll go Shane, right, and a compare function, right? Then mu assert s should be null. Error, wrong answer. So let's try test the array find. Let's pick this up. Okay, so when you run test, we have test underscore darray underscore find, test underscore darray underscore find. Okay. Check 172 label error not defined darray. Oh, check, did I use check anywhere? Oh, alright. So this is a fall through. strcmp. Yeah. Oh, sorry. DRA 84, right? Okay. 84. Compare. Okay, all test passed. Okay, so that's great. Now let's find let's say 13234. 13234, right? That's it. 13234. There we go. Great. I'm just curious. Let me just print s. There we go. Okay. Okay, so there it is, and I have completed this and this. Alright, so